Assalamualaikum, my name is Muhammad Dambari Bayus Paliza, number metric B0819104331 from 2BAI1. Today I gonna introduce or present on Lab 5 Control System Fundamental, which is time response analysis for second order system using MATLAB. Firstly, for procedural, we type capital H equals to transfer function, open bracket, for close, sorry, 1 to 10, close it and close the whole function, semicolon. To display the transfer function as a graph, we use the command step plot H, and we get this step response graph. In this graph, we can get peak response, settling time, and rest time. This is important in transfer function or in control system in general to find these three parameters in a response. Besides that, we can get these parameters using data step info H. Okay, enter, and we get this data in numericals. Basically, the complete data from the graph. Okay, done with the procedure. Now we go to the assignment. For me, I settled the first and the second part of the assignment. Okay, so we clear the command first. Do not show. Okay, first H equal to TF bracket 24.542 and 1 for 24.542. Step plot. This is an error of invalid expression. I forgot to close the bracket, so step plot H, and we get the graph from those parameters. Okay, on the second part is to prove the peak time, to get the value from graph, which is peak time rise time, and settling time. So from this, good. We go to peak response, settling time, and rise time. For rise time is about 0.297 second. Peak time is 0.695, and the graph start to settle around 1.7 second during the process. And the percentage overshoot we get from this graph is the V peak minus V final um, divided by V final at times with 100%. So V peak is 1.25, and the V final we get is, in steady state error, is 1. So we get 25%, 25% overshoot, which which is unstable under damped step response. Thank you, and I will pass this to Ozier. Thank you.
Hello, Assalamualaikum. My name is Muhammad Ozier bin Hasri. My ID number B0819106165. I pair with Adam Bari. So I will continue with number 3 and number 4. Alright. First, we need to declare transfer function hash. Hash equal to transfer function in bracket 1000 close open small bracket 110 51 1030 bracket 3 alright, and then press enter. So we got the transfer function in formula, and then we need to show the graph plot. We must type step plot in bracket hash, and then press enter. Yeah, this is it, our graph. And then to show the all data, we need to type data equal to stat info in bracket hash, and then press enter. Alright, so this is our graph, and this is our data. So the graph beginning with stable and new stable state, and then in the end of the graph is very unstable. So that's all for number 3. Alright, next I will continue with number 4. First we must insert the variable for S3 1 variable for S2, 103, 0, then just enter. For variable S1, we need to create a formula. We need to do that. 103 minus 31 bracket divide by 1, then bracket 0 minus 0 bracket divide by 1, close. 103 because cross section 1 multiplied by 103, negative 31 because 1 multiplied by 31, and 0 because 1 multiplied by 0 is 0, and 0 is 1, 2 is 0. And press enter. Okay. So the answer is negative 72, and then it must be, I don't know why, usually it must have 0 and 0 here. Okay, next, for variable S0, S0, we will create formula 2, bracket, negative 10, bracket, 0, minus, 0 minus, with 103 multiplied by 103 multiplied by negative 662, right? So we get the answer is negative 7416, right? But because it's negative and negative, it will be positive. Bracket and divide by negative 62. Oh, sorry. Divide by negative 72. I'm sorry. And negative 10. Bracket 0 minus 0. Bracket divide by 1. Bracket. So, this is my answer. For sure, it must have 0 and 0 here, because this program only show the answer only. For any, the answer is not into 0. Alright, thank you. Oh, by the way, the system is unstable. So that's all for me.